I will turn it over to Seth and Ubiquant to introduce themselves, and then we will have you share your screen and your presentation, walk through your findings. If they have any questions, they may ask that as they go or save them for the end, and then we will wrap things up at the end. Any questions, Anton, before we begin?
No questions, but I can't share my screen. I couldn't figure out how to do this in mobile. I'll just talk. Yes.
So I have your presentation, so I can present for you.
It's not necessary. I can just talk. It's sufficient to just talk, I think. Then it's just bullet points. It's not necessary, I think.
Okay, I'll go ahead and share the slide just because I know there are. I see your bullet points here. Just easier to follow along visually. If you will just be sure to advance me whenever those slides are.
Okay, I can do that.
All right. Well, then I will fade to the background here. Anton, just please let me know when to move to the next slide. And Seth and Ubiquant folks, I'll hand it over to you. The Ubiquant team, would you like to introduce yourselves?
All right. So we are the AI department from the Ubiquant team, and the two of us, including Xu, who's already in the interview, are the main interviewers who's going to be asking the questions. But yeah, if we have any questions during your presentation, we will we'll ask them as the presentation goes on. So that's pretty much outside of the introduction. I think you can begin your presentation right away.
Okay. So this is my Ubiquant Marketplace 8th place presentation. I guess it's 7th place now. And Kaggle just provided me with a template. I guess they did the same for the competition as well. I noticed the competitions always have the same kind of formula to them. They always have the same details and whatever. So them providing these templates, everything is very well organized. I think they do a good job with that. Everything's standardized. So for the agenda, let's go to the agenda. First, I'll provide some background. Yes, yes, that's exactly. It's the right slide. So what helped me in this competition, and I'll give a short summary, and then more detailed stuff, and finally some questions and answers. So to the next slide, please. Yes, background. As the first, my background. My background mostly lies in self-taught physics. I studied physics for 2 years by myself in my free time, and because it interested me basically. And after that, I felt I needed some practical application of the principles I learned in physics and way to go about things in physics. And I found an application by modeling sports and the esports betting market. And I regularly post on Reddit under the username lowentertainment2621, which is just a automatically generated username. So there's no meaning behind it. And since posting on Reddit, I have like plus 50 units in sports betting and 100 units in esports betting. So it's going very well. And I've also been approached by a bookmaker to work in Malta, but right now I'm not in a position where I can move that far away. So right now I'm just doing this as a hobby. And sports modeling is in some sense very similar to financial predictions, because you're trying to predict future outcomes, and so yeah, it's kind of similar in that way. So maybe that helped me. I don't know. So that was my background.
I actually am curious. You say you have prior experience in the esports betting market. Are you the taker of the? Are you the taker or the maker?
I'm just a better. So I look at the odds on from the bookmakers, and I try to find value.
I see. So you don't decide the odds. You basically look at the odds from all sorts of betting websites and choose which to bet on, right?
Yeah. Of course I have my own odds, but I don't provide a bookmaking service, so I don't take bets from other people. So I just take the odds and take bets from the other bookmakers, so to speak.
All right.
So that was my background. Now to the summary. So the next slide, please. So a very quick summary. I basically just assembled a bunch of machine learned models together, and I will talk about this more later. And the time to train is just with Kaggle notebooks simultaneously on CPU is around 5 hours. So that's just a quick summary of it. Well, we will talk about later. So to the next slide, the feature selection. So I first talk about something. So let's talk about something else first. So the way I understand it from smart people who do a lot of investing, what they do is in traditional investing, they just basically read a lot of financial statements. They listen to earning calls. They try to really understand the people behind the company and also maybe look at the competition. And they do this for weeks and weeks and really try to understand where the company comes from, where it's at, and finally where it's going. And then they try to build a model based on projected revenue growth with some discount rate. And they try to model basically a fair price for the company based on this projected revenue growth. And then they compare it with the current price and decide if it's worth investing or not. Of course, this competition was very different. A traditional investor would tell you it's basically impossible to predict the stock market on any one particular day or maybe even a month. They would tell you maybe in 2 years you can see some pattern behind it, basically to see if it's worked or not, your model. Of course, in this competition you're getting daily features for a very wide array of different stocks, and of course a traditional investor, they would maybe focus on only one sector, maybe like the entertainment sector or something. So this competition was very different in that sense. And so that for there to be any correlation at all to the target, this must be very strong features, and what you're doing must obviously be working very well. And I don't know what these features could be, so I won't try to speculate, but obviously these are very strong features. So let's go to the next slide, please. Yeah, so basically, how did I approach this competition? Well, for anything related to making predictions, in my experience, it's very important to make your model as generalizable and simple as possible. So before I got into any machine learning models, I just tried to really understand something to the nature of the features and how they work and whatever. And I tried to build a model which spits out, using these features, which spits out some, or transformed features, which spits out some number which is proportional to the target. So what I was looking for, I was trying to transform the features in some way, and then by addition and subtraction, so basic operations, just try to come out with a number which has the properties that if the number has a higher positive value, it always correlates well with a higher probability of the target being positive. And if the feature has the output of the model has a high negative value, it must correlate well with a high probability of a negative target. So to the next slide, please. So the transformation that I performed was basically just I took the rolling average of the features and subtracted the current value of the features. And then I just checked if any one of them had this nice property that if the value goes higher, it correlates well with a higher probability of the target being positive, and if it's the negative, it correlates well with a higher probability of the target being negative. So I just did it with all of the features and checked if anyone had these nice properties. And I did it in a way to prevent that I just overfit basically, and I don't really know exactly how I did it anymore, but I did it in a way that that prevents overfitting. I won't list all of the features here, but there are around 15, and you can go through my notebooks and see all of them. Yeah, so that's it. And then to next slide, please. Yeah, then other than that, I took the average of each feature of each time ID as additional features, and the features as they were given by Ubiquant. Yes. So next slide, please. Yeah, training methods. Next slide, please. So for the modeling, I just used the normal machine learning models as you would. So I used gradient boosted trees. And for the gradient boosted trees, I tried various different parameters. There's these lambda and gamma and whatever parameters. And all of these parameters are basically there to prevent overfitting. And I tried a bunch of them, but what I found to basically contain all of these different parameters is the extremely randomized trees feature in the LGBMs. And they had very nice behavior that when you increase the tree number, it always needs to increase and score until it kind of, when you increase it too much, it tapers off, and you can very easily see optimize that without needing to mess with a bunch of lambda and gamma parameters, which are very complicated and maybe lead to overfitting in some sense, even though they are for underfitting actually. And for the neural networks, I just was looking for like an upside down pyramid shape. Basically, I started with a lot of neurons and went down with lower ones and just performed a trial and error parameter sweep. So just basically started a model with some number of neurons per layer or with a different number of layers and let it run for a few hours, and then looked at this result and then tried again with a different architecture. And basically I did this both for the LGBMs and the neural networks for about a week I think. So, and then I finally just please, yes. I finally ensembled them. So what I did, I just took the same models a bunch of time, and the reason for doing this is if you're training your model, you're basically in this parameter space with this loss function, and you're basically trying to find a global minimum, right? Yeah, but you're only finding, depending on your initial conditions, you're only going to find some local minimum that's somewhere close to the initial conditions you set. So what always improves the result empirically I found is that if you take the same model just with a bunch of different initial conditions, so different random seeds or different data shuffles or whatever, this leads to pretty good results. And the reason is basically you start at these very different points in this parameter space, and you're always going to get stuck in some local minimum depending on your initial conditions. And it kind of prevents overfitting if you just take average of different initial conditions and take the average of the results you get from these different initial conditions. And the people on Kaggle do this all the time, and it just empirically it improves results a lot compared to just taking one model with one seed or something like that. So for the ensemble, it depends a bit on the data, I think, on the data structure and what data you got, how many exactly you want to ensemble. But in this data set, I found that if I ensemble 10 LGBMs and 30 of the same neural networks, it works very well. And for validation, I just used the last 25% of the data, so nothing special. And then finally, I just did a trial and error with regard to the weights. And what I found out is I take the average of the LGBMs and also the gradient boosted trees and the neural networks, and multiply that by 0.8, and take the hand-built method, which I talked about earlier, and multiply this by 0.2, I get the best results in my validation. So basically that's what it is. So I'm happy to answer some questions. Otherwise, I'm fine if we end early. I know it's in Europe it's very early, and in America it's very late, and in Asia it must be around lunchtime. So I don't mind if we keep it short. But if there are any questions, I'm happy to answer them. The competition was very fun for me. I learned a lot from it, and yeah.
The first question that I wanted to ask was, you said you picked a lot of models. For example, you picked different, I'm assuming you picked different numbers of neurons and different number of layers for each different neural network. So
yes.
Did you try, did you just handpick the 30 best models, or did you like have any methodology for choosing which neural networks to keep and which ones to throw away?
Well, it was just a trial and error with the validation set. So I just picked some neurons, and then I trained it on the train set, and tested it on the validation set, and just looked what improved results. So I just let the model run for 2 hours, and after that I saw what the results were, and if I made some changes, if it improved the results or reduced the results. So I maybe, for example, I started with 10 epochs, and then I tried 11 epochs, and then let this up and just saw how the score developed, and then just choose the best scores, basically.
I see, but that's how you choose one neural network, right? You chose you added 30 different networks.
The 30 neural networks are actually the same. They have the same architecture. It's just with different seats, basically, with different.
I see. So basically, they have the exact same architecture. The only difference is that they start with different initial parameters.
Yes, exactly.
I see. All right.
它那个 NNG 也是什么结构？你有听到吗
？NLP 就是从到
那个 hand built model 呢
What was the exact architecture of the hand-built model that you mentioned?
You can go through my notebook. I don't have it at hand right now. Or if you can go on the slides, Edison, please go on the slides back. Yes, exactly here. So what I just did, I took the features which are listed here, 33 to 293, and I basically took the average of the features, the rolling average. So I over the time period, I took the rolling average of the features and subtracted the current value of the features, and that's then I just added these together. And then I did the same for the next features that are listed there, the features 15 to 250. And I performed the same transformation, and then I just subtracted these features. And then this spits out some number, and this number is roughly proportional to the target. But without knowing what any of these features actually mean, I can't tell if that actually makes any sense. It's just what I found by just randomly trying out things. So I don't know if it's actually if there's any meaning behind it.
Yeah, I understand that those were the things that you did to the features, but what we wanted to ask was the architecture of the hand-built model that you showed us in like the second to last slide. You said you had like 10 LGBM models, 30 neural network models, and 1 hand-built model. So what did the hand-built model look like? Did it use those features that you previously mentioned?
Yeah, it uses exactly the transformed features I mentioned earlier, and I just added and subtracted them. So this then spits out some number, for example 0.7, and when the number is 0.7, it's like 55% probability that the target is positive. When it's like
so basically it's a completely statistical model and does not require any sort of training. Is that?
Yes.
I see.
Yes, exactly.
All right. 它做了个纯统计学意义上的。
它的电动车列的起后25%，你问他有关谈过这个和 public 的一个关系？
才去了最后20%多少？
20好像。
啊，
因为它跟 public 有什么关系？
Did you happen to notice what your public ranking was, and how did it compare to your eventual private score?
So my public ranking was around place 800. It was a score of 0.15, and my private score, of course, there's a big gap between the public leaderboard and the private leaderboard. So there's no guarantee that the model is using its up-to-date information and stuff. So the private leaderboard was like 0.12 or something. I don't really remember. So 0.0t gap between the private and the public.
All right. So if you were rank 800, did you try to do anything that improved your public rank, or did you only use the validation score as your metric?
I only used the validation score, and finally I used the entire data set to train the model once again.
I see. I see.
提到那个数模型的时候，它是调那个等距离，搞那个人数特别大。因为这个用这个方法不用这个方法，这差别很大。
You said that you selected a very large number of rounds for your tree models. Did it make a very huge difference between using rounds like 100 versus these large numbers of rounds?
Yes, it made so basically, for example, the rough pattern of it was like for 2,000 rounds, the score was like 0.13. For 3,000, it was 0.14. For 4,000, it was 0.15, and then for 5,000, it was 0.155, and then for 6,000, it was 0.15 again, and then it started going down again. So that was roughly the.
人数越多，那你分数越高。
对，是的。然后它到了6000多了之后才会减。Are there any questions from the other interviewers?
Hello. How do you split your train and validation dataset? You use the time series split?
Yes, what I did, I just took the data. It's like sorted by time ID, right? So it's time ID 1 to 3000 or whatever. And then I took the first 75% of the data as training, and the last 25% of the data as validation.
Okay. Do you set a gap between the training dataset and your validation dataset?
I did actually play around with that, and I got like results which were like 0.02 lower, but I didn't use it finally as a validation set. But I did play around with it. Yes, that's a good idea.
Okay, good. Okay, 我这边没有问题了。
All right. I think that's all the questions that the interviewers here at Ubiquant wanted to ask.
All right. So thanks again.
I was saying, Anton, do you have questions for us or for the Ubiquant team?
No, I have no question.
All right. Well, thanks so much for your time. As I mentioned, you were the last presenter, so you'll see some prize money heading your way soon. To the folks at the Ubiquant team, my apologies. I'd forgotten that Seth was out of office this week. We'll schedule time for a final debrief and conclude our competition together. Thanks, everybody. Much appreciated. We will talk again soon.
Thank you.
Thank you. Bye-bye.
Bye.
他说的。